Welcome to the third lesson in our series. As you can see, we've set up our setup a little differently. Hopefully this will help you be able to see a little bit better and hopefully be able to hear us a little clearer. We're going to go ahead and get started. So far in 6.1 and 6.2, we have talked about what a polynomial is, how to put it in standard form, and we've discussed the zeros of a polynomial. If you're looking at your check sheet, let's see if I can zoom in here, you should be able to see that the first two were from 6.1 and then the second four were from 6.2. We're going to go ahead and tackle these three right here, dividing a polynomial using long division, dividing it using synthetic division, and we're going to talk a little bit about the remainder theorem. So let's get started. Once again, here are our Here are our lesson objectives. The first one is to divide a polynomial using long division. The second one is to divide the polynomial using synthetic division. Some of you may not have heard of that. That's okay. It's a much easier way of dividing, so I'm interested to see what you think. So let's go ahead and get started. All right, our first definition is the remainder theorem. And the remainder theorem says that if we have some polynomial p of x, and it has a degree greater than 1, so this can't be a linear equation, and we divide it by x minus a, which is a linear factor, where a is some constant, then the remainder is the same as if we had plugged a into the problem or into the function. So you'll get to see what that looks like when we actually do an example. Alright, so synthetic division, the definition for that is, it's a simplified process of dividing the polynomials where we're going to omit the variables, so omit the x's or the a's or the y's or whatever we're using, and we're also going to omit the exponents. The big thing that you have to remember here is that it has to be a linear equation that has a coefficient of 1. So we'll take a look at an example of that. So let's start with our first example. We're going to divide this polynomial using long division. If you need to, go back and review the video that talks about long division without polynomials. Alright, so x squared plus 2x minus 30, we're going to divide that by this linear equation x minus 5. So the way we set that up is just like we would for regular long division. We put the thing we're dividing by on the outside, and then on the inside we put our polynomial. Make sure to account for all of the exponents. This is a quadratic, so the first exponent was 2, the second one was 1, the third one was 0. If this hadn't had an x term in it, we would have needed to put a 0x in here. Alright, so the process for using long division, the only thing that we're really going to care about is this x squared and the x. And so we say, how many times will x go into x squared? Or what's x squared divided by x? Well, it's x. And we put that up there. So just like the video said, we're going to think of dad, mother, sister, brother. So first we divided x squared by x, and we got x. Next, mother. Multiply. X times x is x squared, and x times negative 5 is negative 5x. The next person we need to think about is sister, so subtract. So change each of the signs. So this was positive, we made it negative. This was negative, we made it positive. And now add these things together. So x squared minus x squared, that's 0. I'm not going to write anything there. 2x plus 5x is 7x. So now we bring down, we think of brother, and we bring down our last term. And we start the whole thing over again. So the first person we thought of was Dad. Divide 7x by x. Well, that's positive 7, so we put that up there. Now Mother. Multiply 7 times x is 7x. 7 times negative 5 is negative 35. Now Sister. Subtract. Let's change the signs for each of these. This positive became a negative and the negative became a positive. And now we add 7x minus 7x is 0. Negative 30 plus 5 is 5. There's no more terms to bring down, and this isn't 0, so this is our remainder. So the way that we would write this, at the bottom of your page, it says the quotient's the thing up here at the top, x plus 7, with a remainder of 5. Or we write it as x plus 7, comma, r 5. Okay, we just figured out how to divide using long division. So let's figure out how to check a factor. So we have a linear expression and we want to know, is this a factor of this polynomial? So will this go evenly into here? So we're just going to use long division, the thing that we just did. This is the thing we're dividing by, so we write that first, x plus 2. And then our polynomial goes underneath here. X squared plus 10x plus 16. We took into account to make sure that we took care of every term. We started with 2, 1, 0. All right, let's think of our family again. So Dad, divide. X squared divided by x, that's x. Now Mother, multiply. X times x is x squared. X times 2 is 2x. Now Sister. Sister says subtract, so we change all the signs. This plus becomes a minus. X squared minus x squared is 0. 10x minus 2x is 8x. And then Brother, bring down this last term. So plus 16. All right, let's start over again. 8x divided by x is 8. Now Mother, multiply. 8 times x is 8x. 8 times 2 is 16. And now Sister, subtract. Change that positive to a negative. Change this positive to a negative. And when we add them together, 8x minus x is 0. 16 minus 16, well, lo and behold, look at that. The remainder is 0. So when the remainder is 0, that means that, yes, x plus 2 is a factor of this polynomial. It was so much fun to check that factor on the last polynomial. Let's do the same thing again. So we're going to divide this polynomial by that linear expression. So x plus 2, x cubed this time, plus 7x squared, minus 5x minus 6. So it's only a factor if the remainder is 0. So let's see if we get a remainder of 0. So first we divide. X cubed divided by x is x squared. And now we multiply. X squared times x is x cubed. X squared times 2 is 2x squared. Now Sister, subtract. Change that positive to a negative. Change this positive to a negative. It's nice that I have a dry erase board. Sorry, you have a paper and pencil. All right, let's add these together. X cubed minus x cubed is 0. 7x squared minus 2x squared is 5x squared. Now, brother, bring down just the next term. We'll deal with that 6 here in a moment. All right, let's start over. Divide. 5x squared divided by x is 5x. Now multiply. 5x times x is 5x squared. 5x times 2 is 10x. Now, sister, subtract. Change that positive to a negative. Change this positive to a negative. And add the two together. 5x squared minus 5x squared is 0. Negative 5x minus 10x is negative 15x. Now let's bring down our last term. This is where writing very carefully and very neatly comes in very handy, because if you lose track of what you've brought down, it'll make it a little messy. All right, so let's divide one more time. Negative 15x divided by x is negative 15. Multiply. Negative 15 times x is negative 15x. Negative 15 times 2 is negative 30. And now we subtract. Sister, change all the signs. This negative becomes a positive. This negative becomes a positive. Negative 15x plus 15x, well, that's 0. But negative 6 plus 30 is 24. We don't have a remainder of 0. Our remainder is 24. So no, x plus 2 is not a factor of this polynomial. All right, let's go ahead and go to our third example. If you haven't done so, make sure you pause the video and do the quick checks for the problems that we just did. All right, so let's talk about synthetic division. So synthetic division is kind of a shortcut to long division. The only thing that we need to think about is that this has to be a linear equation, and this number in front of the x needs to be a 1. All of our constraints are satisfied, so we can use synthetic division. So let's set it up the same way we would for long division, and then we'll move from there. So the thing that we're dividing by is this. So we put x minus 3, and then the polynomial underneath here. 5x cubed minus 6x squared plus 4x minus 1. And if we look back at our definition of synthetic division, it says that it's kind of a shortcut, but we're going to ignore the variables and the exponents. And if you remember before when we did long division, we always talked about sister. We subtracted. We changed the sign on each of the numbers. So that we're not subtracting, so that we're adding, instead of looking at this as a negative 3, we're going to change the sign and this becomes a positive 3. And we put this in the box over here. All right, now because we're ignoring the variables and the exponents, we're just going to bring down these coefficients. So my first coefficient is a 5. The next one is a negative 6. Make sure you bring the sign with it. A positive 4, and finally a negative 1. We need a line under here. Make sure you have some space here. All right, so synthetic division, the way that we do that, we've set it all up. First thing we're going to do is we're just going to bring this 5 down. And we're going to always multiply and then add. So 3 times 5 is 15, and we put the 15 right here. And then we add these two things together. Negative 6 plus 5, that's 9. Now we multiply again. 3 times 9, that's 27. And then we add these together. 4 plus 27 is 31. And finally, 3 times 31 is 93. And we add these two things together, so 92. This last number, that's always your remainder. Okay, so the thing that we would have written up here, we're going to write down here. We're going to subtract 1 from the exponent in each case. So now our new polynomial after we divide by this is 5x squared instead of cubed, and then plus 9x plus 31 with a remainder of 92. And that's synthetic division. Make sure that you do the quick check. Have a great day.